Students' t-test is one of the most commonly used techniques for comparing two groups or populations and determining if there is a significant difference between their means or averages. The null hypothesis states that the population means of the two groups are equal, while the research or alternative hypothesis states that the population means of the two groups are not equal. To illustrate how the t-test works, consider case 1 and case 2, where the difference in the means is being compared. In both cases, the difference in the means is noted to be the same. However, the probability that the green group is different from the blue group is much higher for case 1, where the sample variability for both groups is much lower. That is, the values are a lot closer to the middle value or the mean. Consequently, there is much less overlap between their distributions. Therefore, in order to identify the difference between the means of the two groups, the t-test must measure the difference in means relative to the variability within each group. There are two types of t-tests, the paired and unpaired t-test. In paired t-test, your samples are related since they consist of the same test subjects. You collect data before and after some manipulation or treatment of your subjects. An example of this would be capturing cholesterol levels in year 1 and year 2 for the same set of individuals. On the other hand, the unpaired t-test is the type that is used when you have independent samples. That is, your samples are not directly related to one another, since both samples consist of distinct test subjects. An example of this would be comparing miles per gallon of US cars and Japanese cars. In the succeeding tutorials, we will demonstrate the application of t-test in website A/B testing and process improvement. In this demonstration, we will assess the effectiveness of a new variant of the landing page of an e-commerce website in increasing average order size.
A/B testing is a randomized experimentation process wherein two or more versions of a web page or element are shown to different segments of website visitors at the same time to determine which version leaves the maximum impact and drives business metrics. In our example here, the metric of interest is average order size, or the average amount of money a customer spends in one transaction on the website. Here we are given two versions of the landing page on the website. Since no visitor can be shown both versions of a web page or element at the same time, the appropriate hypothesis test to use to determine which of the two versions are more effective in driving higher average order size is independent t-test. Recall that paired t-test is designed to compare the means of the same group or item under two separate scenarios, while independent t-test compares the means of two independent or unrelated groups. So to perform A/B testing on these two landing page versions, we will perform independent t-tests. But before jumping into that, we first need to confirm whether the variances between the original landing page and the new landing page are the same. So to do that, just go to data analysis, and then you see here the F-test to sample for variances. So just choose that, then click OK. For variable 1, let's select everything under landing page A. And then everything under landing page B for variable 2. Since we selected the column names, let's just tick this option here. Let's retain the level of significance alpha, default value here. Then let's change the output options from new worksheet line to output range. Then let's just select this first cell in this space provided for us, and then click OK. So as a rule of thumb, if this value here, which is the p-value, is less than or equal to 5%, then we reject the null hypothesis of no difference in the variances and accept the alternative hypothesis that the variances are significantly different. Otherwise, we can conclude that the variances between the two samples are the same, or rather the two populations are the same. So why is that important? Because for t-test, there are two variants that we can see from the data analysis toolpack. So if we scroll down, we'll see here the t-tests available from this tool. And as you can see, one t-test assumes that the two populations have equal variances, and the other one assumes that the populations have unequal variances. So going back to the result of this F-test to sample for variances, since the p-value is greater than 5%, then we can assume that the variances between the visitors of landing page A and landing page B are the same or are equal. So again, to run the independent t-test, so let's go to data analysis, scroll down and choose t-test to sample assuming equal variances, then click OK. For variable 1, again, let's select everything under landing page A. For variable 2, let's highlight everything under landing page B. Then for this one, this part, the hypothesized mean difference, if we set this to 0, what this means is that the average order size for landing page A is equal to the average order size for landing page B. So let's just put 0 there. Tick this option here, labels, because we've selected the column names. retain the 5% level of significance. And then for the output options, let's select this cell here, this space provided. Then click OK. So for this t-test, we are given two p-values. So one for one tail and another for two tail. So one-tailed t-tests can detect differences between means in only one direction. So for example, in our case here, alternative hypothesis here is that the average order size for landing page B is greater than the average order size for landing page A. Now, for the two-tailed tests, they can detect differences in either direction. So greater than or less than. So looking at these results, so for both p-values, they are greater than 5%. So